All right. Welcome to the show, everybody. This is Jeff Vollmer. I am a GMAT and EA instructor with Manhattan Prep. We are looking at some content related to some statistics on the quant side of things. It's going to be strictly problem-solving related questions today. Yes, there are quant aspects to a lot of stuff on the DI section. Could have done some stats related questions with like two-part problems in particular. Tables and graphs have a lot of that, but just seems like there's already a lot to cover today with median, average, and some weighted average concepts. And that's already a lot to cover in an hour, so we're just going to stay focused on problem solving here today. Would love to get some feedback with y'all in chat when you have it. Let's get some good participation going. Cool. All right, so I've got the screen share over here. I am sharing a Zoom window so I can annotate, and I will do my best to navigate all the tech things. I'm a GMAT expert, not a tech expert, but I'm going to try my best here. All right, so median, average, weighted average. We're going to start at the beginning. Just with some basic definitions. We'll ease in with some little practice problems, and we'll get to tougher concepts as we go. Median. What the heck is a median? It's some measure of the center of a set, and in particular, we're going to define the median as when you place a list of values in order, increasing or I guess decreasing order, depends on which way you look at the set. The median will be the middle value. All right, so let's quickly kind of run through this. Take a moment. Let me know in chat when you have an answer to this intro questions. We'll warm up. Make sure the keyboards are working. I'll monitor the chat on my other window here. Very good. Cool. Alrighty. So we can define the median as the middle of the list of values when placed in increasing order. So the first thing we should do is just arrange this in order from least to greatest or greatest to least. With 5 terms, maybe you can do that in your head. As you get more and more terms, it's better to just take the time and write this down. You don't want to make a careless mistake on a problem that is very, very solvable. As we know on the GMAT, missing easy questions is a huge bummer. And so let's just kind of guarantee that we are getting those right and we're not taking any shortcuts. So we're going to put this set in order: 2, 3, 7, 8, 9, 8, 10. And of course, 7 is the middle value. So 7 would be the median. Okay. Average, another form of center. Sometimes average and median can be the same. A lot of times they're not. We know average as we're going to sum up all the terms in a list and we're going to divide it by how many terms we added. And so let's just go ahead and take the average of the same set. Give you a moment to knock that out. I promise the questions will get more difficult. That's right. Sometimes we'll see the average referred to as the arithmetic mean. Yeah, technically, there's a handful of different means out there. The arithmetic mean is the one that you really need to know. And another name for arithmetic mean is just average. So we're going to sum all these things up. 10 plus 7 plus 8 plus 2 plus 5. There are ways to group this, right? You can see the 8 plus 2 is 10. The 7 plus 3 is 10. We have another 10 here. That's 3 10s or 30 divided by the 5 terms is 6. So the median would be 7. The average would be 6. Very good. All right, let's put both of these concepts together in a little problem here. Give you a bit of time for this. I'll give you some mini problem. Give you like, I don't know, a minute and a half to do this one. Send me an answer in chat when you've got it. Thanks for some responses in chat from the group. Love it. Give you a little bit more time here. Yeah, and of course, this isn't an actual GMAT problem because there are no answers. There will be answers on future problems. All right, so reasonably straightforward problem here, especially if we kind of understand what average and median are as we just defined them. And so we just need to kind of figure out, hey, what is the average of the set? What is the median of the set? And compare them. One thing that makes this problem relatively straightforward is the numbers are already presented in ascending order. So finding the median is just as simple as figuring out when these numbers are in order, which one's in the middle, but we'll go ahead and do the average first because that's the one we're looking for, the one that's listed first. So we add them up, get a total of 56. You can check my math there. Again, what I would do to make this faster is I would just look for groups. So here's 10, 4 and 6 is 10, that's 20, 7 and 8 is 15, we're at 35, 35 plus 21, 56, divided by the 7 terms is 8. And then the terms are already in ascending order, so the median will be 6. And the difference between 8 and 6 is 2. So thanks for all the people who gave me an answer in chat. Thumbs up for 2 here. So we can see that average and median don't have to be the same value. But occasionally, and in a lot of sets that the GMAT gives us, the average and the median will actually be the same value. What might be some conditions when these two values of a set are equivalent? Can you think of any? What kind of sets would have an average that's equivalent to the median? There's like multiple different types of sets that do this, but the one that's most common on the GMAT are what we would call symmetrical sets. And in particular, what we'll call uniformly spaced sets. So that is where every kind of term is spaced from the other terms by the same amount. So something like consecutive odd integers or consecutive multiples of 8 or something like that. Yeah, an evenly spaced set is always going to be symmetrical. And it's really nice to kind of just visualize this on the number line, like from the middle point, right? Our line, think of an axis of symmetry here, a mirror at 5 in this particular set. The spacing outwards is mirror image left to right. Okay? But there are also symmetrical sets that aren't uniformly spaced. Like imagine if I just moved the 3 and the 7, each a space outward. Okay, the middle is still 5, right? And you can see there's still that type of symmetrical spacing outwards from the 5. And so we'll say, yeah, both of these sets are symmetrical, meaning the average and the median will be precisely the same number. But the first set is evenly spaced or uniformly spaced, whereas this one is not. So the same properties. Cool. All right. So can we use that to our advantage, the average and median being the same thing? Okay, well, let's kind of look at a quick series of problems where this is useful. Let's take a look at this mini problem here. We'll call this problem number 2. There's going to be 3 more on the page. Just like you to sum up the integers from 1 to 10 and give me an answer in chat for me. We'll start small here and then we'll build up. Check 45 again. Close, not quite. Check 45. There we go. Nice. Did we forget the 10 or did we do a different kind of calculation mistake in there potentially? Cool. So I think like adding up the integers 1 through 10 is something you could just do by hand. But I want to show you a shortcut for these types of problems because there are going to be potential sums you have to do where like doing them manually is not really feasible in the amount of time we have on this exam. And so I want to kind of show you a potential shortcut. All right. So one thing we know from our average equation is that, right, average is equal to sum divided by, right, the number of terms. But what we can actually do with this equation is we can flip it around and we can say, oh, that means the sum would be equal to the average of all the terms times the number of terms. Okay. And so we can actually use the average to find the sum. So often we use the sum first to go find the average. But actually, if it's possible, if we can find the average first, we can use that to go find the sum of a series of numbers. And what we want to remember is, hey, consecutive integers 1 to 10, those are all uniformly spaced. This is a symmetrical set. I can remember here that the median equals the mean or the average. And so if I wanted to look at the numbers from 1 through 10, I could say, well, there are 10 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 terms there. And what is the average value of them? Well, you could find the average a couple ways. One way, though, is to think about, well, what would the median value be from 1 to 10? And the median value here would be, you could write them all out, or you could just say, well, if I go to 5.5, the number that would be right in between my two middle terms, there would be 5 numbers to the left of it, 1, 2, 3, 4, 5, and 5 numbers to the right of it, 6, 7, 8, 9, 10. And so the median would be 5.5, and I know that the median is the average in one of these symmetrical or uniformly spaced sets. And so I can now figure out my sum by knowing there are 10 terms, the median or the average is 5.5, and multiplying them and finding out the sum is 55. Okay. Other ways to figure out the average of an entire set of symmetrical terms or uniformly spaced terms is just find the average of the first and last term. The first and last term here, the average of those two terms will be the dead center because of that level of symmetry. And so the average of 1 and 10 is 11/2 or 5.5. So a couple ways to knock that out. All right, so if we are on board with this type of thinking and this potential shortcut option, now we can actually apply this to larger sums. All right, so definitely you could have counted 1 through 10 and added all those numbers up. Do not actually add up numbers 1, 2, 3, 4, all the way to 100 manually. Let's try to lean in on one of these shortcuts. And I will recommend that we carry these ideas forward. Give you a little bit of time here. Let me know in chat when you have an answer. It is not just 550, and it is not 5,500. Cool. Spoiler alerts in the comment section here. You can check your answers and see if they agree with some of your co-participants. Another 30 seconds here. And so there's like 10 times as many numbers in this sum. And the sum is quite a bit larger than our first sum, but it doesn't actually take that much more time or that much more effort to get there, right? So these problems kind of scale rather quickly, but the degree in difficulty does not scale as quickly, right? So sum is equal to average times the number of terms, because again, we can just invert that average formula. Again, we're so used to finding the sum first and then using it to determine the average, but there's nothing that says you have to find the sum first. We could actually find the average first and use it to find the sum. From numbers 1 to 100, there are 100 terms. hopefully that makes sense. If you just counted from 1 to 100, you would have counted 100 terms, but you could also do the whole, if I want to determine how many integers there are in a consecutive string, I find the range, which would be 99 here, and add 1. Either way, 100 terms in the set. So we'll go ahead and put 100 here. And now we got to figure out the average or the median, because those are the same. And so 2 ways to do this. You could just average the first and last term, 1 to 100. 1 and 100 is 101, divided by 2 is 50.5. And 50.5 or 50.5 should make sense as a median, because again, I want that median value to be such that half the terms are below it and half the terms are above it. And if I choose 50.5, right, dead center between 50 and 51, half the terms 1 through 50 are below it, and then half the terms 51 through 100 are above it. So our average should be 50.5. And if we multiply those, well, multiplying by 100 just swings the decimal over twice, and I should get 5,050. 5,050. Yeah. Cool. Question came in the chat. Will there be a calculator available during the test? Only for the data insights section. So you can use a calculator for the data sufficiency problems, table, graph, multi-source reasoning, 2-part questions if you want. Sometimes the calculator is very useful. Sometimes it's not necessary, but you do not get a calculator for the quant section of the exam typically. Yeah. Cool. I should put an asterisk there and say there are like rare accommodations that are possible that can get you a calculator, but pretty rare. Cool. All right. So just scaled up from 1 to 10 to 1 to 100. Let's do one more here. I think this is a legit level GMAT problem. Maybe the first 2 are too kind of plain to be on the GMAT. I do think this third one, though, is more GMAT-like. So if you could just knock out this third one, I'll give you 2 minutes for it, because I guess I just said it was pretty GMAT-like. Let's try this third one. Let's see if we can use these kind of shortcuts we've already talked about to do it. Quick shot, that seems a little too large for me. I think it's going to be a little bit too large. I don't know what your name is, but IV Vonder. That looks pretty good. I think I know what happened, Rickshot. I could try to diagnose what happened, maybe, because I don't think 648 is not a random number. I think it's a way we could get there if we make one little mistake. But let's go take a look at, this problem. Sum of all the multiples of 3 from 15 to 39 inclusive. So I want to make sure I'm adding 15 and 39 in this mix. They're part of the sum. And there's a couple ways to do this, but rather than trying to like think for a minute, like what's the most clever way to think about this set? Maybe just spend like 8 seconds and write out the numbers just so we know what terms we're dealing with. And here they are. Here are the multiples of 3 from 15 to 39. And so from here, you could just count the number of terms. We count the number of terms. There are 9 terms. Now, is there a better way to kind of think about why there are 9 terms? One way to think about this is like, 15 is like the 5th, I'm going to call it the 5th multiple of 3. And 39 is the 13th multiple of 3. Right. And so if I want, it's like, say there were people in line, there's like a line of a lot of people, and my friend is the 5th person in line and I'm the 13th person in line. Like from my friend to me, like how many total people is that? And this is very similar to just saying like, oh, if I counted from 5 to 13, like how many numbers would I count? And when we do that, we take the range, right? 5 to 13 is a range of 8, but I actually I'm not counting the distance between me and my friend in line. I'm counting the number of people that make up those that distance. And so, right, I could say, oh, there are 8 little gaps here, right? But 8 gaps are separating 9 terms. And that's why when you find the range, which would be 8, you always add 1 to actually figure out the number of terms and not just the number of gaps. So there are 9 terms here. Maybe just the easiest way to do it is just to list them. But here's like another way you can think about it. Okay. What's the average? Well, a couple ways we can figure out the average, but this might be one of these times where we really lean in on this idea that the median is the average. And so maybe it's easier to just find the median value than it is to find the average. And here's the median. 27 has just as many terms below it as it does terms above it. And so I guess the average is 27 here. And if we do 27 times 9, look at these, all these powers of 3. 3 to the 3rd times 3 squared, 27 times 9 should give me 3 to the 5th, or 243. Yeah. I'm thinking if we got to 648, the way we would do that, we would have done that, would have been what? We would have somehow gotten 9 times 72 instead of 27. Like maybe we just flipped the 27 and 72, and 9 times 72. Not really sure how we got to that. Yeah. All good. Yeah. We did 24 times 27. 24 times 27 would give us 648. And yeah, the range of these numbers, 15 to 39, the range is 24. So range and number of terms, got to make sure that we're on board there. All right, so yeah, this would be 243. I don't have that in quotes, but I'm going to put it in a double circle so we know that that's the answer here. Okay. And so yeah, this is kind of an interesting relationship of like median, average, and when they can be the same and how we can use them. And so I would say the big takeaway here is, hey, if a set is symmetrical, the average and median are going to be equal. Okay. And that can be really useful for adding up, sets of numbers that are symmetrical or uniformly spaced, right? So if a set is symmetrical, the average and median will definitely be equal. It does not hold in the opposite direction. If the average and median are equal, the set might be symmetrical, but it also might not be, right? Like, so here's an example where we see 5 is the median. And if we add up all the terms, 1 plus 3 plus 5 is 9, plus 8 is 17, plus another 8 is 25. The average is also 5, 25 divided by the 5 terms. And so the median and the average are the same, but we can see that this set is not symmetrical. Okay. So if a set's symmetrical, this is like if a thing's a square, it's definitely a rectangle. If something's a rectangle, it's not necessarily a square. Remember, they took geometry off of the exam, though. The one exception to this, though, I'm doing like another but, the average and median are equal, the set won't necessarily be symmetrical unless you're just dealing with a 3-term set. If there's only 3 terms in your set, there's actually not enough kind of diversity in the terms to have the average and median be equal and to avoid symmetry. So like 1, 2, and 3, right? Clearly symmetrical because they're evenly spaced, right? And 2's in the middle, and 2 would also be the average. Change the gap size here, right? Now they have gaps of 12, so uniformly spaced. 31 is the middle number, it's also the average. And then if all the numbers are the same, the median is the average as well. So a 3-term set, if the median and average are equal, it'll be symmetrical. And if it's symmetrical, the median and average are the same. There's just not there's not enough flexibility with a 3-term set to avoid the symmetry in this case. Cool. All right, let's take a look at another problem. Another problem kind of builds on this a little bit. We'll see how you feel about it. Give you a couple minutes. This one looks more GMAT-like, doesn't it? Give you a couple minutes on this one. Thanks for the honesty in chat. All right, that's been 2 minutes. Yeah, trickier problem maybe than the other ones we've been doing. Also one that's a little bit harder to kind of brute force in just a few minutes because there's like 3 things you have to try, right? The 4 consecutive ints, the 5, and the 6 consecutive integer options. So maybe like brute forcing this is like, it's just too tedious. But I'm getting answers mostly B and E here in chat. And which means you think you can do this with 5 consecutive integers, right? Everybody thinks that Roman numeral 2 works. And can we prove that? Can we prove like how 5 consecutive integers could add up to 130? Do you have, which 5 consecutive integers are those, for example? Is there a way to do it without kind of brute forcing it? Can you theoretically solve it? Rather than have to be like, well, what if I start with like 10, 11, 12, 13, 14? Does that get me there? It's too small. What about like 30, 31, 32, 33? That's too big. Is there a way to do it quickly? All right, well, let's kind of draw this out for the 5 consecutive integers. 1, 2, I like putting little dashes here to organize. These honestly are probably too close together because I'm not going to be able to write that small. All right. If 5 consecutive integers, if they could add up to 130, well, consecutive integers are uniformly spaced, right? There's a symmetrical set. So what I could do is just see like, oh, if 130 is the sum of 5 things, what would the average value be? Right? What would the average value be if 130 is the sum of 5 terms? So we could do 130 divided by 5. Let me actually just bust out the pen here. 130 divided by 5. Sometimes dividing by 5 is annoying, so I'll just double and divide by 10. That's the same as 260 divided by 10. Oh, that's 26. So the middle term could be 26, and that's good because if the middle term was like 26.1, I would be in trouble, right? 26.1 cannot be the average because the average and the median have to be the same. And I need the median value here to be an integer. And so the fact that 26 is an integer, it can serve as the average because it could serve as the median. And so we now would just make this the middle of consecutive ints, 24, 25, 26, 27, and 28. And that should work. All right, so I feel good about Roman numeral 2 here as being something that's definitely true. So I am going to knock this stuff out, put a check mark or a heart next to Roman numeral 2, and that allows me to knock out actually only answer A. There's 80% of the answers have 2 as an option. So let's try the same thing with Roman numeral 1, okay? Like, can you find me 4 terms that add up to 130 if the terms are all consecutive integers? What could those be? It's tricky because now the median, right? The median value doesn't actually exist in the set. Right? If I have 4 terms, the median is defined as the average value of these 2 middle terms. Right? So if I have terms like 1, 2, 3, and 4, the median is 2.5. Right? And so is the average here. Okay? So in this case, like the median of 4 consecutive integers will not be an integer. It should be halfway between 2 consecutive integers. So it should be a 0.5. Right? And maybe we could hunt this down. Like let's show you what the trial and error could look like and then show you a faster way to do it. So I could say like, okay, what if this were 20, 21, 22, 23? All right, 20 plus 21 is 41, plus 63, 86. All right, that's not high enough. So I got to go up more. Let's go up to 30, 30, 31, 32, and 33. All right, 30 plus 31 is 61. Plus 32 would be 93. 93 plus 33, 93 plus is 96, plus the other 30, 126. All right, so I'm getting closer. I'm at 126. And so I'm 4 away from where I need to be. And so what I could actually do here is I could just say, oh, well, if I increase each of these by 1, then the sum would go up by a total of 4, which would be where I want to get to. So let's go ahead and just knock out this 30, move everybody else down a row, go this way, down a dash, 33, and now we get 34. And this should actually sum up to 130. Okay. And so another way we could think about this is we could say, okay, if 130 were the sum of 4 consecutive integers, what would the average value be? Right? And so we could say 130 divided by 4. Where's the rest of my 3? 130 divided by 4. Maybe not a lot of shortcuts for doing this. Well, I could divide by 2 in both numerator and denominator. That's 65 divided by 2. And I could do something like this. That's 64 plus 1 divided by 2. And so that's 32 and a half. And 32 and a half makes sense as a median here, or an average, because it's right in between the 2 terms. And so if I know the median or average is 32 and a half, I could say, oh, that the integers right around it are 32 and 33. And now I could put 4 integers in a row. And so, yeah, Roman numeral 1 also works here. Roman numeral 1 also works here. All right. So That's going to allow me to knock out answer B. Sorry for those of you who picked answer B, and answer D, because I need Roman numeral 1 to be present. And so now I got to see if Roman numeral 3 works. Can 130 be expressed as the sum of 6 consecutive integers? All right. Well, I would recommend either trying to dash this out, give 6 dashes, and see if you can find the 6 numbers that add up to 130. That seems kind of more work to me than thinking about if the sum were 130 of 6 consecutive integers, what would the average be? And does that work as a median? Oof, dashes need some help with uniformity themselves. All right. So what would the average value be if you had 130 terms, if they were all separated by 1, for example, 130 divided by 6? What is that? Not a lot of shortcuts for dividing by 6, maybe. I guess you could say that's 65 again, divided by 3. And that's, maybe I'll just do this, 66 minus 1 divided by 3. And 66 divided by 3 is 22. And minus a third. So that'll be 21 2/3. All right, this is a problem. And can we figure out like why this is a problem? Like what the average should be 21 2/3. Why is that a problem? Yeah, Alexandra, I think that's fine too. You can just try that. What would have to work there is like x would have to be an integer. Yeah. And what you'd find here is x would not be an integer. Yeah, exactly. Yeah. So 21 2/3 doesn't work here because 21 2/3 is not the midpoint between 2 consecutive integers, right? It is closer to 22 than 21. So it's actually not directly halfway between 2 consecutive integers. So the only way like this would work would be if each of these terms, they could each be 1 away from each other, but none of them would be integers. Yeah, and you could try getting like, if I tried 20, 21, 22, 23, 24, 25, I believe that's going to be a little bit too high of a sum. But if you tried 19, 20, 21, 22, 23, and 24, that's going to be just a little too small. And so it's got to be somewhere between there, but there are no integers in between there. And so that means Roman numeral 3 doesn't work. So it means we want choice C here, choice C. Yeah. Cool. So yeah, understanding that interplay between median and average, or median and arithmetic mean, is an important one. When can they be the same? When must they be the same? When won't they be the same? Both median and average have good uses in the real world, and kind of knowing like how they're different, I would say it's important beyond just studying for the GMAT. Very good. All right, let's do another one. Let's take a look at a different problem. Problem 6. I got a couple more in here I'd like to get through, so let's knock this one out. Got the word average in here. Got a little bit of median stuff. It's a good combo problem. righty, we're at 2 minutes, 2 minutes. Give you a little bit more time here because I'm not getting a lot of answers in chat. Give me another 30 seconds. All right, we're at a little over 2.5 minutes here. Let's go ahead and wrap this up. Can't take too long on any problem. Don't want to jeopardize our success rate on future problems that might be easier for us to solve. And remember, we always have the option on the GMAT, the new version of the GMAT, to revisit a problem. If we have that epiphany later in the section, we realize how to do it. If we have time, we can come back to it. But if we don't have time, because we spent too long on it initially, it's gone forever. All right, so got a set of 5 numbers and the average of them is 50. Let's pause right there and make an inference. All right, what do we know after we get through the first sentence of this problem? A set of 5 numbers has an average of 50. Do we know that the median is also 50? Well, it says that later, but initially we don't know that yet because we don't know if this is a symmetrical set. But if the 5 numbers have an average of 50, I want to immediately stop and say, that means the sum is 5 times 50 or 250. Boom. Yeah. Do I know that they're consecutive? I don't know if they're consecutive yet. Right? They could be 48, 49, 50, 51, 52, or 50's in the middle. But then when I read the next sentence, it's the largest element is 5 more than 3 times the smallest element. Oh, so it can't be just from 48 to 52. So something else is going on here. Okay. So I think what we could do here is we could create a little system of dashes. Again, I mentioned this earlier. I'm a big fan of this just to help organize. Okay, how many terms do I have? What do I know about them? Can I order them from least to greatest, just to help me just keep track of all the information I'm getting? And so far, I know that the sum here is 250. Okay, the largest element in the set, we can call this largest. Let's call this largest. This is 5 greater than 3 times the smallest. Okay, let's call the smallest one S. And then that means I can put this largest value in terms of S. It's 5 more than 3 times the smallest. So I think something like this. Multiply the smallest value by 3 and then increase by 5. That should get me this description. And then it says the median, so this term in the middle, it equals the mean. And they've already told me what the average was, 50. So now I know that this is also 50. Okay, so I'm filling out more and more information. There's still a couple of unknowns here, right? Still a couple of unknowns. All right, this question just came into chat. Why is it not consecutive? When it says the mean is equal to the mean, then the set should be consecutive. Not necessarily. Right? When you have a consecutive set, when you have a set of symmetry or uniformly spaced terms, right? The mean and median are always the same, but it's not necessarily the other way around, right? I had some examples 1, 2, 5, 8, and 9. This has an average of 5. It has a median of 5. These are not consecutive integers. They are not uniformly spaced. So it is possible to have median and mean be equivalent when you don't have consecutive integers, or when you don't even have, when you don't have consecutive integers. You can have just symmetry here. I can also make a non-symmetrical set do this. Let's see, what am I doing here? There. That's not symmetrical, but it should still have an average of 5 and a median of 5. Cool. When there are 3 terms, yes, that will always be the case, but not when there are 5 terms. All right, so how do I make this the largest possible value, right? Like what's the strategy here? If I want to maximize this, what I want to do is I want to conserve other places. Like if I want to have the largest dinner possible and I'm on a diet overall, then I need to have like my breakfast and lunch be relatively small, right? So if I want to make this term as large as possible, then I've got to make the other terms as small as possible, called minimize. Now I still have to follow the rules. Like I can't make this term 0, right? Because 50 has to be no greater than this term. But like I could make this term 50, right? I should be able to make this term 50. And I'm still playing by the rules here, as long as I don't make this term too big. And I shouldn't be making this term too big because strategically I want to make it as small as possible so that I leave as much of my 250 sum, leave it available for this final term. So what is the smallest I could make this term? I think I could make it S. And so now what we have is, all right, S is as small as possible. The second term is as small as possible. The median is 50. It told me that. It told me it was the same as the average. And then the fourth term is also as small as possible. By minimizing these 4, I should be able to maximize the big one. So we're going to say minimize these. And now we have an equation to solve. And the nice thing now is the equation just has one variable, S plus 50 plus 50 plus 3S plus 5. So how many S's is that? 5 S's total plus 105, 50 plus 5 equals 250. Now we can solve for S. 5S equals 5S. We don't need to add another variable here, right? 5S equals 145. And so what does S equal? S equals 145 over 5. Or another way to write that, just because I've been doing this already today, 150 minus 5 divided by 5, which is 30 minus 1, which is 29. So if S is 29, then what's 3S plus 5? Well, 3S would be 3 times 29 is 87. Don't forget to add the plus 5 to get to 92. Right. So here's a problem that involves stuff related to average, sum, median, but also has this other wrinkle of maximizing a value. Right. So we're going to use all this given information, lay it out with kind of a nice framework here. I'm a big fan of these dashes to kind of hold information and organize. And then strategically, if I'm dealing with like a set sum and I want to maximize one value, well, you can only maximize one value if you steal some of that from other terms. Okay. Like this is the exact opposite of what you should be doing on the GMAT, like time management wise, right? You have a set amount of time and you could spend like 44 minutes on the last question and like 2 seconds on all the other questions. That would be not what you want to do, but you could. In this case, we do want to do something like that. We want to try to make this spot as large as possible from our set sum, which means we have to shrink these as much as possible according to our rules. There it is. Yes, Sebi, I love that. I think that's really, really cool. Sebi was like, well, if we know that the final answer is 5 times 3S, then maybe I could just look at the answers and be like, which of these is 5 more than a multiple of 3, right? And D is, right? We know D is the right answer. And I guess A is as well. A is 5 more than 81. And 81 is a multiple of 3. That does assume that S is an integer, which sometimes we can get in trouble with, but I think on a problem like this, that's typically going to be the case. It doesn't say they're all integers, but if they gave you a problem like this and it also involved fractions and decimals, that would be truly diabolical. So not a bad instinct there. I like that. Yeah, pretty cool. Very good. All right. Let's take a look at something else. All right. So I did kind of tease this, and so we're definitely going to go past the bottom of the hour here. But that's okay. I already voted today, so I got nothing else to do right now. We're going to go to the concept of weighted averages, and this is something I could spend hours doing, but we don't have hours, so I want to give you the kind of the quick and dirty way to think about this, and hopefully you leave with some some strategies or some kind of tricks that you might be able to apply to similar types of problems. But let's just kind of show what we mean by a weighted average. So we're going to do this by going bowling and bowling a couple of different scores across the games. So let's say there's a bowler. After 2 games, the bowler has scored 100 and 160. What's the average score? Okay, fairly straightforward problem. You could literally just add these two, divide by 2, or you could say, you might just be able to visualize like what's in the middle of 100 and 160. And you would say, well, 130, Jeff. This is too easy. And I would say, yeah, this is probably too easy to ever be on the GMAT for just about everybody. Okay, but let's scale this up. Okay, we're going to start small, and I want to be able to visualize this with this stuff with you, so that you can apply these concepts on tougher problems. And the last problem we do today, I think, is pretty tough. So you have that to look forward to. All right, so let's now have the bowler bowl 3 games, and they score 100, 160, and 160 again. What's the bowler's average score now? Give you a little bit of time to think about this. And I think this is one where you could just add up 100 plus 160 plus 160 and divide by 3. Totally cool. In fact, if you did that, I would applaud you and say there's no real reason to do anything other than that. But hopefully what we can see here is that the average is not going to be 130 anymore, right? Like after the first 2 games, 100 and 160, this person's average was 130. And so then when they bowl another 160, like that should have a positive effect on the bowler's overall average because it's higher than their previous average. And so it should move the average up from 130 a little bit more. And as some people have said in chat, it ends up being 140, which makes sense. It's higher than 130. But is there a way to kind of know exactly like, oh, it gets to 140 and not 145 or not 138? Like I know it should be closer to 160 than to 100. Like if I were to balance, like literally if I were to balance these 3 bowling balls on a board, I couldn't do it here. Like this board would tip downwards over here. So I'd have to move kind of my balance point. This is kind of a nice visual to see that. I have to move the balance point or the average position closer to the heavier side and further from the lighter side so that the heavier side has kind of less of an effect force-wise on the board. And the lighter side has more of an effect force-wise on the board. So here's the way that like I like to think about how to know exactly where the average is between these 100s and 160s, right? And there's 3 ways I think I can communicate this, right? And you can they're all equivalent. They're all mathematically the same thing, just different kind of wording. You've bowled 3 games. 2 out of the 3 are 160. The other one's 100. And so because 2 of the 3 games are 160, the average will be 2/3 of the way from 100 to 160. Think of this on a number line. The distance between these 2 scores from 100 to 160 is 60. And 2/3 of that distance would be 40. And so we're going to put the average 2/3 of the way from 100 to 160. I'm going to need to look up what that word means. Aditya, I will say that mixtures and mixtures are like a type of weighted average problem. In fact, the last problem I have today is a mixture problem. I don't know what an allegation means here, and so I might have to look that up. Maybe this is why I don't teach the GRE. Okay, so 2 out of 3 games are 160s. The average will be 2/3 of the way from 100 to 160. Here's another way to think about it. There are twice as many 160s as 100s. So like the 160s should have like twice the effect on the average. And the way to visualize that is the average will be twice as close to 160 as to 140, right? It's 20 away from the right side of this diagram. And it's twice as far, 40 away from 100. Or just invert that. Oh, there are twice as many 160s as 100s, so the average will be twice as far from 100 as 160. Literally the same thing as saying it's twice as close to 160 as 100, but the term twice as close seems a little strange. Right? I think we all know what twice as far is, but twice as close seems a little weird. So all of those three are exactly the same. You can kind of take whatever you want there, okay, and try to apply it to this next version of the problem. All right, so now the bowler has kind of hit the hot streak, bowls the 100 once, and then hits 164 times. So 5 games, got 100 once, 164 times. What's the bowler's average score? You can do it the old school way where you just add these up and divide by 5, or you can try it with this proportion fraction way. Let me know in chat when you have an answer. It's close, not 140. There we go. There we go. Yeah. Yes. Good job. I'll give you a little bit more time here. Stuff in 148 factorial would be wild. We could do that real quick. 148 factorial has how many trailing zeros? That's a good one. I think 35. All right. Cool. All right. That's been close to 2 minutes here. Very good. Is there a trick in distance-wise if there are more than 2 distinct numbers? So if like the bowler got 100 and 120 and then 164 times, much harder to do this when there are more than 2 components. When there are 3 or 4 components, really tough to do a weighted average problem with these tricks. There's a way, it's probably not worth describing. At that point, there's probably a different way to solve the problem, or just solve it kind of the more traditional way. Yeah, that's what I'll say there. There are ways to do it, but it's really not worth. It's like the divisibility rule when like to determine if the number is divisible by 7. It's like, yes, there's like technically a rule for that, but it's just probably just faster just to divide it by 7 and see if you get an integer. All right. Bowler scored 100 once, 164 times. We're going to draw this out. I am running out of vertical space here for my bowling balls. And there's no chance that these are actually going to stay on top of each other. All right, so what's the bowler's average score? So we could just add up 164 times. 16 times 4 is 640. 16 times 4 is 64. So 160 times 4 is 640. Plus the 100 is 740. 740 divided by 5. You could knock that out. Or you could say, well, of the 5 games, 4 of them are at 160. So the average should be 4/5 of the way from 100 to 160. From 100 to 160, that's a distance of 60. What's 4/5 of 60? And that's where the average should sit, on the way from 100 to 160. Similarly, you could just say, there's 4 times as many 160s as 100. So the average should be 4 times as close to 160 as 100, or the average will be 4 times as far from 100 as it is to 160. And so that would be 148. Yeah. So how would I do this last one? This last one, I would say, okay, 4 times as far from 100 as 160. I'd probably I kind of eyeball this and say it's about here. I don't know exactly where it is yet, but this distance and this distance are in a certain ratio. I call this D for distance. And I'll call this 40 for 4 times the distance. And say, well, the entire span is 4D plus D, or 5D spans the 160 to 100 gap. So those 60 points. And if 5D is 60, then D is 12. And I can say, we are at 12 less than 160 or 148 here. So again, all the same, right? I'm literally like, I found the distance is 60. I said, 4/5 of that is 48. That should be 48 more than 100 is 148. So all of these are exactly the same methods, depending on which way you want to look at it. All right, we'll stop with 4 bowling balls. I can't get this picture much higher, but let's go take a look at a different problem. I got 2 more problems here that build on this, and hopefully we can close this out. Let's take a look at this one. It's been a minute. Thanks for the answers, everybody. Love it. There are ways to, we're at 2 minutes here. There are ways to kind of like guess here, I think, a little bit, or at least estimate. So based on the story here, are there more seniors, or there are more juniors, or are there equal number? And how do we know? Yeah, I think the visualizing is helpful here. Yeah, so let's visualize this a little bit. I don't have bowling balls, and I didn't know how to draw little exams, so you're just gonna have to imagine here. But here's the situation. We've got juniors averaging 80s. We've got seniors averaging 86s. And for all I care, like I know maybe not all the seniors got 86s. Their average was 86. It's just easier to think of every senior got an 86. Like I'm going to treat all the seniors as getting 86s, right? And I'm going to treat all the juniors as getting 80s. And so I have a bunch of 80s, I have a bunch of 86s, and the overall average is 82. And this is why you can think of these as mixture problems, right? Like the 82 average is a mix of 80s and 86s. And or the 148 bowling average that our bowler just had on the previous problem is a mix of a bunch of 160s and a 100, right? And so the concept here, I know it's not actually like a physical mixture, but it's essentially the same concept, right? So what we can see here is the average is closer. The overall average 82 is closer to the juniors 80s than it is to the seniors 86s. And because the overall average leans towards the juniors value, there have to be more juniors, right? Like they have more influence on the overall average is the way to think about it. So there are more juniors than seniors, or I could say the seniors are less than the juniors in terms of number. Better test scores, but fewer of them. Okay, so I can automatically knock out D and E. All right. And now it's a question of, well, like, how much more? Right? How does the 82 kind of sit between the 80 and 86? Right? And so what we could say here is, well, I could look at the distances here. I could say, okay, well, this is a distance of 2 points. This is a distance of 4 points, right? Let's call it 2 points, 4 points. Say, the average is twice as close, right? Or half as far, however you want to say it, twice as close to the juniors as it is to the seniors. So there should be twice as many juniors. And that means the seniors to juniors ratio should be 1 to 2. Another way to think of that is to say, in the total span from 80 to 86, that's a distance of 6 points, right? The average falls a third of the way from the 80 to the 86. So the seniors should make up a third of the total, and the juniors should make up, well, the remaining 2/3 of the total. And 1/3 to 2/3 is the same as 1 to 2. That's the way to think about it. And you could confirm, like you could, if you wanted to like plug in the answers, you could be like, well, what if, so let me check this. There's 1 senior, there's 2 juniors. Let me add those up. 86 plus 80 plus 80. If I add that up, 246 divided by 3, I get 82. So you could confirm it that way. It just seems clunkier to like plug those in for all the answers than to visualize it like this. All right, feeling good? Because we got one more, and this one is tougher than the one that's on the screen now. So this one actually reminds me, I think I wrote this problem a little while ago. I wrote it because there's an interesting problem in the official guide that's like this. You probably know it. It's the one that involves ryegrass and bluegrass and fescue. It's towards the end of the problem solving section of the official guide. And then they don't ask you about the fescue or the bluegrass. It's like, why do they even talk about that? So I wrote a problem that was similar to that, but it does talk about one of the other components. Give you a couple minutes to try this, and then we'll wrap things up. Y'all have been great. Thank you very much. It's been 2 minutes. I'll give you all 1 more minute for this one. Is this a mixture problem or what? Yeah. All right. Do any of you know that seed mixture problem I was referring to with the fescue and the bluegrass and the ryegrass? Anyway, this is kind of like it. And yeah, students often ask, like, why do they even tell me the stuff about fescue and bluegrass? And I think it's because a lot of times the GMAT has these problems, like most of the structure is the same, but they can like twist the problem like a little bit here and there to like basically get more mileage out of one setup. And I think in that problem, there does exist some versions, some little like different options to that problem where they ask about the fescue or the bluegrass. And so this is what this problem's like. Maybe sometimes you see that in like critical reasoning problems where you might see like the same argument a couple times, but like the first time it's a boldface argument, and the next time it's like a, an assumption question or something like that. They do reuse some problems and prompts here and there. All right, got some answers in here. It doesn't seem like a lot of confidence and not as many answers, but let's go through this setup. So we have two different drinks. Drink A, majority apple juice. Drink B, also majority apple juice, but more so, 60% versus 80%. And then there's like some orange juice in drink A. 40% of drink A is orange juice. 20% of drink B is grapefruit juice. I have no idea if there are drinks like this out there. They don't seem like they'd be a good color, but I am not a professional GMAT problem writer, and I didn't research a lot of juices. So we're going to combine the two drinks, and the resultant punch is 68% apple juice, which makes sense that that's possible because the first option is 60% apple juice. The second option is 80% apple juice. So the average should be somewhere between that, right? If the majority of the drink were drink A, the average would be closer to 60% apple juice. If the majority of the mixture were drink B, the overall end result would be closer to 80% apple juice. And we get something that's 68% apple juice. So I think we can draw this out. Okay, we're dealing with apple juice here, and eventually I'm going to have to pivot to orange juice. So I'm kind of on notice there. All right, so right now I'm dealing with apple juice, and here's what we got. All right, what can we determine about how much drink A and how much drink B there is to get this mixture of apple juice to 68%? So we could start, is there more drink A or is there more drink B? Like, let's start there. Is there more drink A or more drink B? Well, if they were equal amounts, right, the average would be right at 70, but it's not. This is a weighted average. The average 68%, the final concentration of 68% is closer to this side, meaning there's got to be more of this stuff, right? Like the number of liters of drink A exceeds the number of liters of drink B by some percentage or proportion. So now can we kind of figure out the distribution here? Like how much more? Is it twice as much? Is it 3 times as much? Is it 10% more? What's going on? Whew. So let's get back to kind of like seeing how far the 68% sits from 60 and 80, or how far along the way from 60 to 80, the 68% occurs. And so one way we can say this is, well, there's a gap of 20% here, and this sits 8 along the way into that 20. So it's like, it's 2/5, 8 out of 20 is 2/5. It's 2/5 of the way to 80, right? The final percent of apple juice, 2/5 of the way from 60 to 80. So drink B is that makes up 2/5 of the overall punch, and that means drink A must make up the remaining 3/5. So if we can get to this point, I think we're like more than halfway done. All right, so let's just like let that sink in. Okay, does this distribution make sense? Right? Other ways, I won't write them all up on the screen, but the other ways to think about this was, okay, like how far is the 68% from either side? This is a gap of 8. This is a gap of 12, right? So like, what's the ratio there? Is it twice as far? No, it's not twice as far. It's like, it's 1.5 times or 3/2 as much. So right, so this should be in a 3-to-2 ratio, drink A to drink B, kind of represent that it's 3/2 as far from drink B as it is to drink A. So 3-to-2, you can see the 3-to-2, right? The ratio of part to part versus the fractions related to the entire punch. All right, so if we have that, we're in good shape, because now the only thing that changes in this structure is I don't want to talk about apple juice anymore. I want to talk about orange juice, but I still know that 2/5 of the punch is drink B and 3/5 of the punch is drink A. So now I should be able to just kind of get rid of the apple juice stuff and just say, okay, I still have 2/5 drink B, 3/5 drink A, and now remind myself that I'm dealing with orange juice. Okay, so drink B is 0% orange juice. There's no orange juice in it. It's only apple and grapefruit. Drink A is 40% orange juice. All right, so the orange juice percentage of the punch should fall between 0 and 40. Here are all my answers, between 0 and 40, but it should be closer to 40 than 0 because the majority of the punch is from drink A, which has the 40% orange juice. So it's got to be closer to 40 than 0 or more than 20%. That knocks out A, B, and C. And now we can kind of just use this fractional stuff and say, well, 3/5 of the total is drink A. So the average, the overall percentage at the end of orange juice should be 3/5 of the way from 0 to 40. What's 3/5 of 40? Well, 1/5 is 8, 2/5 is 16, and 3/5 is 24. So drink A makes up 3/5 of the punch. So the final percentage of orange juice should be 3/5, 1/5, 2/5, 3/5. There it is, 4, 5, 3/5 of the way from 0 to 40, which is 24%. And that one I think is a hard problem. We can follow the logic there. You just did 2 weighted average problems in one. Yeah, just got to pivot from apple to orange. That's it. That's a good one. Cool. We have gone for 80 minutes or so now. So I think what we're going to do is try to wrap up here. I will kind of say I've made some of these videos in the past on our Manhattan Prep YouTube channel. And so I have some videos that touch on similar things there. So do a bunch of my colleagues. You can check out in particular ones I know I've done. I've done one on uniformly spaced sets, if you want to look at that one a little bit more. I've done one on weighted averages. It's from when I was much younger and had longer hair. There's also one on, if you're interested in some more stat stuff, I did one on visualizing standard deviation. As you can see here, I'm very much into like visualizing the spatial aspects of these statistics things so that we can see them and understand them better. Yeah. I do have them on probability and combinatorics overlapping sets. There's a bunch of other ones. I was just talking about the statistics-based ones here. Yeah, a lot of videos on there. Check out the channel. Thanks, everybody. Appreciate you. If you put comments in the chat, I will check them periodically and hopefully be able to respond here and there. But thanks for coming out. If you watch it on the recording, good luck out there. Good luck on your journey here. Keep your head up. Thanks, everybody.